Design science is about finding the best practices of design, isolating and extracting them, and determining whether or not they are repeatable. Typically, designers move from the problem statement into ideation, for which best practices and methodologies have been fairly well established. Two of these methods are 635 and mind mapping. 635, or C-Sketch, is a sketch-based ideation method involving 6 people, 3 ideas per person, and 5 rounds of iterative rotation. A single page is given to each participant and broken into 3 segments. In each segment in the initial round, each participant writes 3 ideas. This sheet is then passed left to the participant's neighbor, who then adds on to the original sketches. This passing process is repeated after an interval of 10 minutes 5 times until everyone has commented on each idea. Mind mapping is another ideation method for organizing ideas hierarchically. Subproblems can branch off of the main topic to allow detailed exploration of the design space. Consider ideation of an infographic. We can consider not only the size of the graphic, be it large or small, but also the content, be it word or picture-based. Within this table example, we see that aside from main topics like color and material, there can also be variety within subtopics, such as shape or size within surface. Mind maps also help with exploration. For this technical example, notice how change car, rather than wheel design, opens up other concept avenues for smoother vehicle ride. Typically after ideation, designers begin prototyping, or representing ideas with models rather than sketches. However, there is far more limited research on how to prototype effectively. Currently, we have 2 ongoing studies of prototyping. In the first, we study successful designs in the maker database Instructables, which has over 100,000 entries. We perform analysis on batches of entries for common principles. This may include such tests as how each component is sourced. Consider the large number of components in common products. Additionally, consider the startup time required for a single given manufacturing process. This conflict was identified from examining the database. Thus, we observed many successful products use the same manufacturing process for functionally disparate components. This was only one of about 14 principles we have identified so far. In another study, we analyzed the behavior of designers in silico and review experimental reports of others who have done the same to identify similar principles. Suppose you want to design a prosthetic leg. How do you make choices about prototyping? Explore a method that relates context to prototyping strategy. These context variables, such as budget and time, are related to strategy decisions. Returning to the leg example, suppose that budget is high but time is low. Strategy will encourage the simultaneous testing of several designs in parallel. What if budget were the bottleneck, and we had only been able to develop this rather mediocre single concept initially? In this case, we can iterate, making slight improvements to the design with each test. We have deployed these methods while simultaneously obtaining feedback about their effectiveness in diverse contexts. In Papua New Guinea, our collaborative workshop has led to the development of a revolutionary feminine hygiene product, while at Tsinghua in Beijing, our design participants physically prototyped a working atomic force microscope for high school students that will cost less than $100.